Okay, so today we're going to go over some conditional probability. So the definition of the conditional probability is A given that B has occurred. Let me spell that correctly. Occurred. So we're going to find this as, right, so P, A given that B has occurred, which we can denote as probability of A intersecting B divided by probability of B, where probability of B is greater than 0, right? And then what we can relate this to, what I'm going to highlight this in red because this is also important when we use this today, multiplication rule, right? So this is denoted by probability of A intersecting B, which is equal to probability of A given that B has occurred, multiplied by probability of B. So this is another part of our multiplication rule that we're going to go over today. So an example of this is we have two ways of travel to work, right? So in this scenario, we have nine males, 10 females that are randomly selected, right? So we have 3, 6, 9, 7, 3, 10, and then total on the right side. So we're going to answer these following questions. So the first one, we have to find the probably individual drives to work and is a male, all right? So we're going to do one over here. So we already know probability that the person drives, right? Given probability that the person's a male. So I'm going to combine these two, right? So this is probability that the person drives to work, occurring that the person is already a male. If we go up here, we can see 3 and total 19. So our answer for this is 3 over 19. Pretty simple. All right, so as we move on, we're on number 2. So the next one is find the probability of an individual that drives to work given it is a male. All right, so what is probability they come to work given that the person is a male? So the next question, we still use the same formula, but now using the multiplication rule. Probability the person drives given it's a male. So we can do probability of driving intersecting males divided by probability of male drivers. So we can do this as 3 over 19 divided by, right? So we can do 9 over 19 because that's our total number of males. We can note this as an answer of 1 over 3. All right. So our next one, last one, is the probability of a male taking a bus to work, right? So the probability on this one, right, is probability that a male is taking a bus to work. And in this scenario, we can look up, as we can denote this as male driving a bus, so 6 over 9, which can be denoted as 2 over 3. Simple, right? So using our multiplication rule to do another one. So then I'm going to do an example of conditional probability. Conditional probability, right? So remember that 6-sided die, so we have a 6-sided die, right? We have it 1, 2, 3, 4, 5, 6, right? Probably A, right? Get 1, right? And probably a B, we get an odd. So it's odd number, you get a 1, right? So probability of A occurring is 1 out of 6, right? Probably to get the number 1 is 1 time. Well, the probability of B is 1 over 2 because half the numbers are odd. If we can do the probability of A slash B, so A occurring given that B has already occurred, we can do this as 1 over 3, right? With the conditions of both A and B occurring. All right, so as we move down to our next part, we'll do another example. All right, another example of conditional probability. So this, I actually just wrote this down here, so I'm going to put right here. Okay. Next point, approximately 18% of shoppers look for deals. Probability of making a purchase is 45%, right? what is the probability that the person made a purchase? So we're trying to find what is the probability that the person made a purchase here. All right. So probability of shoppers looking for a deal. So probability of S, we're going to denote as 0.18. And the probability of purchasing, so probably purchase equals 45. So to denote this, we could denote this as, right, probability of the buying it, but also being a shopper at that local store can be 0.45. So for them to shop at the store, right, they have to make a purchase. So that's the probability, right? So to find this now, we're going to do probability of P intersecting C, which is basically probability P given that C has occurred, multiplied probability of C, right? So we can equal this as 0.45, sorry, not C, S. I apologize, S, because we're doing a shopper. Look at another example, I'm sorry. Multiplied by 0.81, equaling 0.081%. So therefore, 8.1% chance of this occurring. So 8% chance of purchase are going to shop at this store and use a deal for the 45%. Okay. The next point is the total law of probability. So this can be, right, A1, A2 to A3, right, to dot 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 AN, right, is mutually exclusive, right, and exhaustive events, right? So we're assuming A is these events, then another for B. Right? So we denote probability. So this is very important. I'm going to start this, right? Total law of probability. Probability B equals, right, the sum of probability B given that A is occurring multiplied by the probability of an A, right? So this can be equal as, if we just do using A1 and A2, right, probability B slash A1 multiplied by probability of A1, and then continuing for 2, 3, 4, whatever number we get, all right? So B could be split up in different parts, and as we do it as well too, in different parts as well, all right? Or we can write this as probability B, A intersects B, plus A2 intersects B, dot, 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 right? I would mostly use this one, just because some of the problems in textbook are going to be in relation to that event. All right, so this probability B occurs in all three or all multiple events of A. So as we draw this, all right, let me try to draw the most shittiest square on the planet. All right, fuck it, it's going to be like this, right? We have A1, A2, and let's say this big circle is B, right? So this is intersecting into A1, A2, and any denotion of A. All right, so we're going to do an example, right? So one dude has 3 email accounts, which is labeled by A, B, and C, right? The first part we're trying to find is our graph down here. So this is our chart. So we have to do question 1, which is find the probability that the random selected email is A and from a spam, all right? So now we have to denote just all the aspects of what we have to write down for this question first. So I'm gonna actually erase this. So before we answer, right? So before we answer, we have to find the following. Okay, so we have to find the probabilities of each email. So A2, A3, right? So this is email A, email B, all right, and email C, right? So we know from this chart, this one's 0.7, this one's 0.2, this one's 0.1, right? as we do this now, we're going to do the probability of P spam, so we denote this is S, right, given that A has occurred, all right? Same thing, S, A2, P, S, A3, right? So we can do this, right, by seeing what spam. So we have 0.1%, 0.02%, 0.05%. So the question that's asking on number one, right, probably selected is from A and is a spam, all right? So how we do this, using the formula of total law of probability up here and the multiplication rule, right? So we denote P A1 intersecting S in equal P S given that A has occurred, multiplied by probability of A. So we're going to note this by 0.01 times 0.7 equals 0.007% chance. All right, pretty simple. So just given two events, what one occurs and one doesn't occur, right? So as we move on, we're going to move on to our next question, which if we scroll up, now we have to find the total probability of the randomly selected email is a spam. All right, so this is a little bit harder. All right, so number two, so trying to find the probability of just spam. Right, so now we use total law probability. Total law, right? So this can be denoted as, since we have three emails, I'm going to use all three. So we have P, spam occurring if we had an email from one, multiplied by A1. So this, we're going to write this again down here. So 0.01 times 0.07 plus probability a spam occurs, but A already is given an occurring, probability A2. This is, right, if we look up, 0.2 times 0.02. Right. Plus, right, next one, probability S given A3 occurs, multiplied by probability of email 3 being used, which is 0.05 times, right, 0.1. This will equal probability of spam 0.016%. All right. So now as we move on, I'm going to go over something also very important to start this as well too, Bayes' rule. So now we're using events B, right, Bn, right, are mutually exclusive. Exclusive and exhaustive. So same thing as before. With the prior probabilities occurring, right? So now we can devote this as if event A occurs, right, the probability of B given A is the following, right? So we're going to write this in red, right? So to do this, right, so probability B given A has occurred. So we can denote this as, right, probability of, sorry, let me write this down, scratch my notes, probability A given B multiplied by the probability of B divided by, right, the sum of the total law of probability, which is P A slash BI times BI. So basically, dividing it by, where is it up? This formula up here. All right. As we move down, right, we're going to break this down in more, but you kind of get this gist if you understand. So this is, right, and this can also be ... total law of probability as below. Okay. So we're going to go over An example. So diagnosis test for diseases. We have first one is every 1 in 1,000 people has a disease, right? The test is not always accurate. Probably the test positive given people has disease is 0.95, so we can denote this. Negative is 0.9, right? So as we go through this, we're going to label some stuff, all right? Label it. So as we label, we can denote D has it, D complementary does not. All right, so probability that someone has the disease is 1 over 1,000, because 1,000 people, right? Every 1 in 1,000. We can denote this as 0.001, right? And we can do tests now. So this is if they test positive. Probability of T complementary is negative. All right. So as we go through this, when we're doing the probability, now we're finding each things of like what the actual question is, right? We want to know what having the disease given the test was positive. All right. So we can find the error that may occur. All right. Want to find this out. Okay. So as we do this, first we're going to go probability T given D complementary, right? So as we do this now, we have equals 1 minus P test negative, disease negative, right? So it's 1 minus, which is over here, 0.9 equals 0.1. Easy, right? We do the same with the other one above, so probability of test positive and has disease, right, equals 0.95. I should have wrote this at first, but that's okay. Negative, doesn't have disease, 0.9. All right. So as we go through this now, we use our formula of Bayes' rule that we just complemented above. All right. So as we do this, went over our Bayes' rule and go over probability. Person has a disease given the test is positive equals probability that person has tested positive and has the disease multiplied with the probability that they have it divided by, right, probability the person tested positive has a disease times probability plus, right, we have our another denotation, which is up here. Right, probability that they test negative and don't have the disease multiplied that they don't have the disease. All right, so we can denote this as 0.95 times 0.001 divided by 0.95 times 0.001 plus 0.1 times 0.999 as we denoted above here, right? So as we do this, right, we know D complementary is 0.9999999, and our answer is going to be 0.0094, which means this answer is very small. Awesome. So next video, we're going to go over independence, so independence of probability, and we're going to go into chapter 3. Alrighty, hope you have a good day. Take care.